What's happening? I want to show you something about water. This is a lake. And as you can see, there's ripples in the water. I have it sitting down on the floor, so I'm trying to see it. Okay, there's ripples in the water. Why are they there? Why are there ripples there? It's not windy. The water should just be sitting still. But because there's a boat out there and a canoe out there and fish swimming around and wind and certain factors that make the water do that, because at certain times, oh look at it, it's starting to rain. At certain times the water will lift up in certain places and it'll go lower than its surface level in some places, so they even out with each other until it's sitting perfectly still. So I have a rock in my hand, and what I'm going to do is I'm going to throw the rock out there, and we're going to watch the water, what is happening to the water. And what is happening is the splash from this rock right here. So the splash from this rock is going to cause the surface of the water around the rock, where the rock lands. It's going to push the surface of the water up in that spot, around the rock. And that's going to create a wave pattern. And that wave pattern is going to come all the way back here to the dock, and we're going to talk about it as it comes in. So ready? Here, I'm not going to throw it too far. Okay, there we go. Okay, can you see that? I hope you can see that. That really didn't show up quite like I thought it would, but I think we can see it. And see how they're spreading out? I don't know if you can see that. I'm going to bring the phone up higher. Maybe that'll help, maybe not. Yeah, you can see those ripples coming towards us. See that? Slowly moving outward from the point that the water's just trying to find its level. I'm gonna step back so you can maybe see as it gets bigger. Can you see where it is now? See that? It's to the dock right about now. And then we can watch all these little waves of higher, lower, higher, lower, higher, lower, higher, lower, higher, lower, higher, lower, which is just a replica of that rock splashing into the water, lifting that water up, and it's going to continue on that wave and do that until it seeks its level. This has nothing to do with gravity. This has nothing to do with anything but the water settling to a perfectly flat, straight line surface that does not follow the curvature of the earth. Because as we look across the lake here, this is only not even 1 mile. It's just under a mile across this lake, I believe. This is Lake George in Minnesota. But if you look 18 times farther than we're looking now to the other side of the lake, you can still see the trees. The houses you really can't see anymore because of if I put my camera right down on top of the water, there's fog that comes off, a slight fog that comes off the surface of the water, evaporating in a way. But can you imagine that we're looking much further, 18 or 15 times farther than those trees we see right there? And what do we see? We just see those same trees there, but they're just obviously a lot shorter in angular, or smaller in angular size. And actually, to the naked eye, 15 miles, you would tell yourself that there is no other side of the lake until you get optics in there. So that's what I wanted to do. I'll throw a bunch of rocks in there since I grabbed a handful. All right, so we're gonna watch them ripple, and then that'll be that. All right, see that? See how the ripples even fight against each other? But some of them cancel each other, the other ones out. See that? That's pretty cool. I'm glad I threw that bunch. So remember that to use your instincts. Oh, there's a beaver or something over here. What is this? Unless that was just a really, really big fish. Anyway, alrighty, you guys have a good day.